Hello, this is Mr. Jackson with physics. Today I want to talk about trigonometry basics. In trigonometry, what they are is there are some formulas that are created to help us solve triangles or situations that have an appearance of a triangle. You have distances or you have lengths or speeds, and they're acting in certain directions that form a triangle. We're going to deal with just triangles or problems that have a 90 degree inside them or a right triangle. So with that idea, we only need to know a few basic formulas you need for trigonometry. You don't need to know all the things about trigonometry, but this is fine. So we're going to deal with just these formulas. I'll mention them right now. We have the sine function formula, the cosine formula, and the tangent formula. And what they do is they have these names. The sine is equal to opposite over hypotenuse. Cosine is adjacent over hypotenuse. And tangent is opposite over adjacent. So I'm going to teach you first, when we get going here, is how to name your sides and how to understand what these names mean. Okay? The next formula we need to know is important. It's called the Pythagorean theorem, which says that side C on a triangle is equal to the a squared side plus the b squared side. And we'll define those as well. These little theta symbols by each of these functions is called theta, but it means an angle because inside of every triangle there's angles in there. And so these angles would go by these or where these symbols are at. Okay? And I'll show you what that means in a moment. But one last thing I want to point out is if you ever have a triangle, all the angles inside of a triangle will add up to 180 degrees, whether one's a 90 degree or not, then they will all add up to 180 degrees. So that sometimes helps us find missing angles. So let's get started and let's just do some basic ideas. The first thing you want to be able to do in any problem that has a triangular type shape to it, you want to assign the names to your triangle. What does that mean? It just simply means that if I give you a problem, let's say I just make something up. Just say that we have walked 10 kilometers, okay, or 10 miles or 10 inches, or at a speed of 10 meters per second. Anything that can be treated like a triangle. And then we have situation turn around. We walk another distance, and we want to figure out how far we are from our original place. So let's say we have this thing right here, but for some reason we have a compass on us, and our compass tells us that we are 60 degrees. That's what this theta means. It's an inside angle. And I want to know this side right here. Okay? Well, here's how it works out. In our triangles will always be a 90 degree. A 90 degree angle makes it a right triangle. The side across from that 90 degrees that it opens up to is always called the hypotenuse. So the longest side of this triangle is the hypotenuse, also known as side C, which is right here. Okay? So the longest side or one that opens up across from along the 90 degree is the hypotenuse. The side that you have that you're dealing with, that if that side touches the angle, that side is called the adjacent. Okay? The side that it opens up to, which is not the longest side, is called the opposite side. Okay? And so if I put 10 here, that makes this side the adjacent. If I had done this, let's say I set this situation up, and I had my angle of 60 degrees, and I had this situation, and my 10 was here, if that 10 was there, and it's opposite the angle, then this is now my opposite. This is my opposite side, and this is still my adjacent side. Okay? And if I move it one more time, let's say that I have my 60 degrees down here. Okay? This is still my hypotenuse, just like this is. Okay, but now because the angle is down here, this becomes my adjacent side and this becomes my opposite side because it opens up to the side, and the side that touches the angle that's still less than the hypotenuse is called the adjacent. So you need to know that when you move the angle, you move and change the names. Here I did not move the angle, so my names didn't change. Here I moved the angle, so my names did change. Okay? So make sure you know what's going on and what side is what, because then you can put your numbers in the correct spots. Okay? So first thing you want to be able to do is make sure you know by assigning the names. You can put them in your head or you can put them on the paper, but make sure you know that information. So let's start solving a problem. Then solve, number 2, solve your situation by choosing the right formula or the correct formula. And that's not hard, because if you have your names, it helps you pick the right formula. So let's make a problem. We have one right here. We have our problem. We have 10, okay, and we have our angle of 60 degrees. And let's say I want to find the hypotenuse. Well, that means that I'm going to need to use a problem that has, since I have an adjacent side and I want to find the hypotenuse, those two names have to be in the formula. The only one that has adjacent and hypotenuse in their formulas is the cosine right here. So I got to use this formula. Okay? So I write it out. The cosine, and theta gets the angle that you're using, 60 degrees, equals adjacent, which is 10. And this can have any kind of units. But remember, if this has meters, then this will be a meter answer, and this will be a meter answer. So you can't get different units. If this is meter per second, then that'll be meter per second, that'll be meter per second. Okay, so whatever unit you have on one side, it's the same answer for all the other sides. So I've got 10 divided by, this is my unknown, so there's my x. Okay, and I've been teaching you in algebra or in physics, to the algebra you need, we can just switch these two. So x will be equal to 10 divided by the cosine of 60 degrees. And so all you need to do is you need to go to your calculator. Now here is where it's important to understand that when you turn on your calculator, you're going to have different kind of calculators available to you. This calculator, if I want to find the sine of 60, I push cosine first, and then I fill the bracket with 60, and then I push equals to get the answer for what that value is. This one does not have as many steps. This one, if I push cosine first, it takes the cosine of the number, which is 1, but I want the cosine of 60. So in this calculator, I have to push 60 and then push cosine, and it immediately gives me the answer. So these two calculators work differently. So be careful, know what your calculator and how it works, okay? So I know the answer is 0.5. So that's what you want to do. But also I want to point out one thing. You see this little degree word here? It is also here. In some classes, they make you use radians, and that's this DRG. So if I wanted to change the mode, I can pick different modes and then enter them. But I want to make sure my calculator is always in degree modes, because we're going to be using these problems in degree modes. So if you change that in any class, make sure you always change it back to degree for physics. Okay? So I'm going to use this calculator right here so you can see what I'm doing. So I'm going to take my equation now, because I rearranged it already, got x by itself. So x is equal to 10 divided by, I push cosine, I fill it with 60, close the bracket. Now it's going to divide those two numbers. It will do the function and then divide. And so I get 20. And so 10 divided by 0.5, so 10 divided by half, doubles the 10. The answer is 20. So x equals 20. Does that make sense? Okay? So that's how you use these formulas, but you need to know their names to help you out. So let's do another problem. Let's say I wanted to find this side right here. And so this answer is 20. let's say I wanted to find this side. Okay, well, I can use either one of these numbers. Let's say for right now, for sake, I still just have this number 10, and I want to find this side. Well, this is the adjacent, and this opens up to the opposite. So I need a formula that has adjacent and opposite in it. But say I don't have this number, so I don't have on the hypotenuse, then I need to find a formula with those two names in it. So I go to my list. The only one with those two names in it is tangent. So I would pick that formula and write it down and then begin to fill the information. So we're going to go down here again. The tangent of theta. And now theta gets the angle you're dealing with equals opposite. So my opposite is my unknown. So I put an X there over adjacent, which is 10. So in this case, the 10 ends up on the bottom. So I can't memorize. I have to use the names to apply where things go. So now I want to solve for the X. I'm just going to multiply both sides by 10. So here's my formula. I go 10 times, whoops, wrong calculator. I want to use the right calculator. Here we go, clear. We have 10 times tangent, and I want 60 in there, and I close the bracket, push equals. I get 17.32. I'm just going to put 17.3, and remember, if it's meters here, it's going to be meters here, and it's going to be meters there. So that's meters as well. Okay? So that's how you would solve that problem. Now I just found all the sides. Well, let me show you how these other formulas work. Let's say that I had this side and this 60, but I wanted to find 20 this way. So let's say I have this problem. Let's put the same numbers down just to show you how these formulas work. Let's say I want the hypotenuse, but I have the adjacent, okay, and I still have this 60 degrees. So how would I find that? Well, I got to label my names. This is my angle. The side that's small that's touching the angle is called the adjacent. The side that it opens up to is called opposite. The longest side across from the 90 degree is hypotenuse. So I need a hypotenuse and an opposite in my formulas. A opposite and hypotenuse is the sine function. So that I'm required to use that one. So I would just write the sine of theta, which is the angle that I'm working with in my triangle, equals opposite over hypotenuse. I want to solve it. Now, if these formulas all work correctly, even though I just changed which one I'm using, I still should get the answer of 20. It shouldn't change how the math works. That's why you have so many options to do these formulas. So let's switch these two numbers again. So we're going to go the x equals 17.3 over the sine of 60 degrees. So I'm going to divide these two numbers. So clear, 17.3 divided by sine 60, close the bracket, equals, I get 19.97. Let's just say I want to round to the whole number, or even I want to round to the second decimal. I don't want the 7, so the 7 forces the 9, the 9, so it all becomes 20. Okay, so you may have some small decimal changes when you're going backwards. The only way to get rid of that to make exactly 20 is you want to carry more numbers. So maybe I should have used 17.3. I think it was 2 out there. So whatever that is, okay? So it doesn't matter what your triangle looks like. You just need to use these names to help you find the right formula, okay? Let's say that you have all side information, but you don't have the angles inside. What would you do then? What if we had our triangle here, and we had a situation where we had this 20 and this 10, and I wanted to know this side, but they never gave us any angles. Well, that's real simple. We just simply use the Pythagorean theorem because it relates all the sides together and no angle information is needed. So we're going to use that, but remember, when you're doing this, the longest side is called C. which is always across from the 90. That's the only restriction. But A and B can be either one of these. It doesn't matter which one you label as A and B. So I'm going to call this one B and this one A, just for naming sake. So I'm going to use the Pythagorean theorem, which says c squared equals a squared plus b squared. I want to solve for A. I'm hoping to get 17.3 if I'm correct, whether I use these formulas or this one. So here we go. My C is 20. And A is my unknown. And my B is squared there too. So to get this to the other side, I would subtract. So 20 squared is 400. I know 10 squared is 100. I'm adding it, so I'm bringing it to the other side. Minus 100 equals x squared. So 400 minus 100 equals 300. So I want to do shift square root, clear, second square root of 300, close the brackets, equals, and I get 17.32. So square root, and so x equals 17.3. So that's how those formulas work. What they do is they help you solve information on different sides of the triangle. So it's just a method that if you have a problem that looks like a triangle, you can find missing information on different sides, okay? So let's try a different kind of problem. Let's go ahead and do one where we have sides and we want to find an interior angle, okay? Well, we can find angles as well because they're in our formulas. So let's just make up a problem again. Let's go ahead, well, why don't we just go ahead and use the same information we've been using so you see it works out perfectly. Let's say that we have our same triangle, okay? And we have this, and we know that this is 20 and that this is 10, okay? And my goal is I want to find this missing angle. So that's what I want to find inside the triangle. So how would I do that? Well, I know I need a formula that has a theta in it. So I'm going to need one of these because there's no theta in here because this is an angle and it must have a theta inside. So I have the side opposite. I have the C. And remember, this doesn't matter if it's A or not, but we also want to put down the names. This is the hypotenuse, and this is touching the angle, so this is an adjacent. Okay? So I need adjacent and hypotenuse. I go up here, that's cosine. So the cosine of theta is adjacent over hypotenuse. Okay? Now I plug my numbers in, but this is my unknown. So I go C, or cosine x, that's my unknown, equals adjacent side, which is worth 10, over the hypotenuse side, which is worth 20. 10 divided by 20 is 0.5. Okay? So the cosine of x equals 0.5. So now what I want to do is I want to get the cosine to the other side. What we've been teaching you is that we would divide out by the cosine, right? And then we get x by itself. But that's not how it works with trigonometry. How this works is if I want to move a name, tangent, cosine, or sine, and I want to move it to the other side, how you do it is you take what's called the inverse cosine of both sides. So you would take this side and you would do what's called the inverse cosine, and then you would do the inverse cosine of this side, and then that would fall away. So I need to do an inverse cosine of 0.5, and it will get me the x by itself. How you do that in your calculator is every sine, cosine, and tangent function has an inverse above it. So I want to get rid of this cosine by using an inverse cosine, a minus 1, 1. But I have to do the same thing to both sides. So I'm going to push second cosine, and you notice the negative 1 comes up, so it means I'm taking an inverse cosine, and I want to do that of the 0.5. 0.5. And if you have numbers, let's say you have numbers like 0.53481, you want to at least carry 3 decimal places. If you round this, your degree numbers will really be random and become far away than my answer. So be careful. This one just happened to have only 1 decimal. And I close the bracket, and I push equal. And now it's going to give me the degree answer for what I was solving for. So x is 60, and that's a degree. So whenever you use an inverse cosine, you are finding a degree answer. So it says this angle right here is 60 degrees. And we knew that because we've been starting off with that problem all along. Okay? Now, let's use this idea right here. If this is a triangle, and I know this is 60 degrees, and this is 90, because I'm always working with 90-degree triangles, then what is this angle going to be? Well, I can use trigonometry, this up here, or I can use this idea right here. All 3 angles should add up to 180. So I'm going to do a quick little fix here. I know that 180 degrees should be all 3. It should be the 60 plus the 90 plus the unknown one right here, this theta right there. Okay? If I want to put a theta there, I can do that. Okay? So all I got to do is bring these to the other side. So clear. 180 minus 90 equals minus 60 equals 30. So what I'm missing is 30 degrees. Okay? So that was one way to get a quick answer, by knowing that all these angles must add up to 180. But let's say I want to use my formula. Let's say I want to find this one, and I know that this is 10, and I know that this is 20 from above here. And let's say I want to find this angle using another formula that has a theta in it. So I name my sides. This is the hypotenuse. This is this side I'm using. I'm looking for this side, so that makes now this name the opposite. This side is adjacent, so it's touching it. So I need to use, since I have this number, I need to use an opposite and a hypotenuse. Opposite and hypotenuse is the sine function. So I write down the sine of unknown theta, which is what I'm trying to solve for right here, is going to be equal to opposite, which is 10, over the hypotenuse, which is 20. Okay? And I want to solve for this theta. So what I'm going to do is I'm going to take and get rid of the sine function by taking the inverse sine. That cancels out the sine, but not the theta. But I got to take the inverse sine of this side too. So I'm going to simply go 10 divided by 20 equals, there's that number, and then I want to take the inverse sine, so I go shift sine, there it is, and I had 0.5, close the bracket, and it gives me an answer of 30 degrees. So theta equals 30 degrees. So I just found the same side a different way, but using a sine function. So you have multiple options on how you want to solve things, okay? So that's how trig works in a very simple way, okay? That's what I wanted to show you today.